This is section 8.4 of accelerated geometry. The topic is area of a sector, a segment, and an annulus. So this is a picture of a sector, this is a picture of a segment, and this is a picture of an annulus. Okay, we'll start with a sector. A sector of a circle is the region bounded by an arc and two radii which cut off that arc. So that is the definition, and that is what it looks like. It looks like a piece of pie or a piece of pizza. Okay, when I look at that, I think a sector is not a whole circle, it is a part of the whole circle. So therefore, its area would be part of the area of a circle. Another word for part would be fraction. A sector is a fraction, a part or a fraction, a piece of the area of a whole circle. Now, the area of a whole circle is pi r squared. So now I have a sector is a fraction of a circle. Of, in math, is a times sign, and now I have to deal with this fraction. To figure out what fraction it is, there's 360 degrees in a circle, so there's 360 degrees around here. There's also 360 degrees around this edge here. Okay, so the sector is a fraction of that circle. To figure out that fraction, I would say the degrees in the arc in here, or the degrees in the angle, they're both equal. Okay, so the degrees in the arc or that angle over a whole 360, that's going to be the fraction that this pizza slice is of the whole area of the circle. So therefore, the formula for the sector of a circle is the arc measure, so the number of degrees in the arc, over 360 times pi r squared. Now, there is no number for this conjecture on the conjecture list, but it is after conjecture number 72 in section 8.4. So area of a circle is the arc measure or the angle measure in degrees over 360 times pi r squared. Okay, here's an example of using that. Find the area of this shaded sector. So the first thing I do is I write down the formula that I'm going to use. The area of a sector is the amount of degrees in the angular arc over 360 times pi r squared. Now, what do I know? I know that the degrees is 45, so that's my A, and I know that the radius is 20, that's my R. So I substitute in an R of 20 and an A of 45. 45 over 360 reduces to 1/8. 20 times 20 is 400. 1/8 of 400 is 50. So therefore the area of that sector is 50 pi. It's in centimeters and its area, so it'd be square centimeters. Here's another example of a sector problem. The shaded area is 14 pi square centimeters and the radius is 6. Find out what x is. So find out what that angle, that A is, that angle which is the same measurement as this arc. Okay, so I use the formula. The area of a sector is A over 360 times pi r squared. The area is 14 pi, so that's going to go in here. The radius is 6, that's going to go in here. So now 6 squared becomes the 36. Then I think what we did is divide 36 into here once, and 36 goes into there 10 times. So you get A over 10 times pi. Then they both have a pi, so if I divide this side by pi and the other side by pi, the pi's will go away. And then if I multiply both sides by 10, I will have A alone being 140 degrees. So there's the formula for the area of a sector and two problems that deal with it. Now we have a segment of a circle. It's the region between a chord. So a chord is just a line segment in a circle with endpoints on the circle. So it's the region between a chord and this included arc. Okay, if I look at that, I can take the whole pizza slice, which is the sector, and subtract this triangle, and I'll be left with the segment of a circle. Okay, so now this is the area of a sector, the number of degrees over 360 times pi r squared, minus this is the area of a triangle, and so therefore that becomes my conjecture. So add this also to section 8.4 where it says area of a segment. Now I have an example that uses the area of a segment formula. So find the area of the shaded segment. So that is a segment of the circle. The formula is the number of degrees in the angular arc over 360 times pi r squared. So that's the fraction of the whole circle. So that would be the area of that whole piece right here. But then we're going to subtract out this triangle, and then we will be left with the area of that segment. Okay, so now what do I know? This angle is going to be 90. The radius is going to be a 6. And in the triangle, the base and the height that meet at 90-degree angles, this is 6. The other radius is going to be the same, 6. So this is going to be a 6, and so is that. So when I plug that in, 90 over 360 becomes 1/4. 6 squared becomes 36. 6 times 6 becomes 36. 1/4 of 36 is 9. So this is 9 pi, and half of 36 is 18. So it'll be 9 pi minus 18 square centimeters. And our third formula for today is the annulus of the circle. It is the region between two concentric circles. Concentric are circles that have the same center. So this is a concentric circle with this one. They both have the same center. And the region between those two is the annulus. So it's a ring. So this is what they say. If I take the area of the whole big outer circle, which they didn't make big enough here, and subtract out the inner circle, I will have the ring. So the outer circle, they say, let's make that have a radius of capital R, and the inner circle, let's make that have a radius of a small r. So pi r squared, area of a circle, minus pi r squared, area of a circle, is going to be the annulus. So add that also to your conjecture list in section 8.4. And now I have two problems that deal with an annulus. The first one is pretty straightforward. Find the area of the shaded region. Capital R goes from here to here, that's 7, and small r goes from here to here, that is 4. So we write down the area, which we should always do. We always should write down the formulas that we're going to use. So here's the area of an annulus formula. And now I substitute in the stuff I know. Capital R is 7, little r is 4. 7 times 7 is 49, 4 times 4 is 16. 49 pi minus 16 pi is 33 pi. This is in centimeters, and its area, so it'd be square centimeters. And here's our last grand finale problem. Find the area of the shaded region. Well, it used to be an annulus, but now it's not the whole annulus. Now, how much of an annulus do I have? There's 360 degrees in a whole circle all the way around. and 60 of it is not going to be used. So that means I'm using 300 degrees out of the 360. So this is what I say. The area is going to be 300 3/60ths of an annulus, which is pi capital R squared minus pi little r squared. And over here they tell us what they want capital R to be and small r to be. So I substitute those in. These zeros cancel out, and if I divide the top and bottom by 6, I got 5/6. R becomes a 12. Little r here becomes a 9. 12 squared is 144. 9 squared is 81. 144 pi minus 81 pi becomes 63 pi. So they did a division here by 3. 3 goes in there twice, and 3 goes into there 21 times. So the top would be 105 pi, and on the bottom, a 2. So that would be my answer in square centimeters. So I think you are now ready to start your homework and to dream about those pie slices, those pizza slices.